Welcome to Java Space. In this video, we are going to talk about top mistakes or topmost mistakes that we must avoid as Spring developers. So, one of the mistakes that we need to avoid is not reading the documentation. You know, Spring frameworks come with a wonderful documentation and it's free. And from my own experience, I have noticed that the best way to learn Spring is to read the documentation, because the documentation has so much that you cannot even imagine. Too much information. You can actually become a Spring certified or even Spring master or an expert just by reading the documentation, because the documentation has been done so properly that it becomes very easy for you to study the framework. You can become a good Spring developer if you are consistently reading the documentation. So let's read the documentation. So the first mistake I want to talk about is regarding the transactional annotation. So I'm just going to go in code. So this transactional annotation, before I go into code, is provided by Spring, and it's also there in Java EE or Jakarta EE. So we're just going to see that quickly. If you come here, you see that this is Jakarta EE specification. So as you can see, we don't really have much in terms of functionality and attributes. We just have 1, 2, 3. This is the Spring one. It has much more than you see. You can specify transaction manager. You have the label. You have propagation, isolation level. You have timeouts. You have read-only, and many more. So Spring will recommend you to use their own transactional annotation because it gives you much more things, like more flexibility. You can do quite a lot with it. Alright, that's the first thing. The second thing I want to highlight is with regard to the read-only property of the Spring transactional annotation. So a lot of us, we tend to just use the transactional annotation just like that without specifying any attribute or setting any property of it, and that is not a good practice. So if you look at this method, let's assume this is a service, not a control, and we are applying this to a service method that find entity by name. This method is clearly a read-only operation. It does not do any database changes. So why, if it doesn't do any database changes, why can't we specify that it doesn't do database changes? Like, why can't we just say read-only equals to true? You might be asking, what is the benefit of that? Let's go to the documentation. So the documentation says a Boolean flag that can be set to true if the transaction is effectively read-only, allowing for corresponding optimizations at runtime. So you see that when you specify the read-only, the Spring runtime will optimize the transaction for you, will optimize the operation for you. Okay, let's see in a much bigger, broader sense. So I have this class here. It has quite a number of methods in it. Some are read-only, some are not read-only. So what you will typically want to do, or normally want to do, is you will declare a transactional annotation at class level and say read-only. which means all the methods in that class will inherit that property. But for methods that do write operations, then those methods you can basically override the class level annotation with the method level annotation, which now will bring back the read-only to false, because the read-only, as you can see, is given a false value by default. So this is what you want to do. Why are we saying read-only is false? Because we are doing a database change. So you can actually do that. So that is what I wanted to highlight with regard to a transactional annotation. Mistake number 2, omitting the final keyword in our dependencies. So before I explain more on this final keyword, let's see what I mean. So I'm just gonna come back to my Spring Boot application. As you can see here, I have a dependency employee repo as is here, and we have all argument construct, and we know that this is similar to this. This is similar to this, but because we are using Lombok, we wanna let Lombok create this boilerplate code for us. All right, so what you wanna do is make your field final, and when they are final like this, you can now you can even use the @required argument construct, which would say this will generate a constructor argument, sorry, a parameterized constructor for all final fields in your class, because if it's final, it must be initialized in a constructor or in an initializer. If it's a final like this. So why do we have to do this? We are doing this because obviously this is still a debate in the Java world, but this will help the compiler to perform code optimizations for you, because there are like lots of things that happen through compilation until code, bytecode actually gets into the JVM, and a lot of things are happening. I explained that in my series on Java. So if your field is final, it will allow the JVM or the compiler to perform code optimizations for you. So always make your fields final, but don't confuse this final with immutability. When your field is final, like we do have here, it does not mean this is immutable, because I can still use do this dot set something, this dot set something, which will then change the state of this controller. So that is what I wanted to clarify, because sometimes we tend to confuse final fields with immutability. All right, that is fine. So let's go to mistake number 3. So one of the coding principles that we learn is our project or application must have separation of concern. So let's come into our controller. There's something I want to show you. So if I come to this, I believe it's this. Okay, let's use this control. All right. So see what we are doing here. I'm just going to make this final. See what we are doing in this at employee method. We are doing some validations here, and if the validation does not pass, we throw an exception. So this code clearly does not belong here. A controller is not supposed to handle any business logic. In some situations, you might find code where they are even doing some looping, filtering, doing some filtering in a controller. This is not allowed. All right, let's run this code. I will call this method post so that we can see what I want to highlight. Post, mistake number 3. Okay, let's come here. Mistake 3, post. All right, so full name is, we are expecting full name to be, not to be less than 2, okay, in length. So let's see, we have an exception, name invalid from, this is the exception that we threw. But as I said, this is not a good practice. We can remove these validations from a controller because it's not the controller responsibility to do that. So how can we do that? All right, so this is an employee object that has all these values. So I have introduced employee constraint. As you can see, this one now has some constraints, but for you to use this constraint in your Maven, you must include Spring Boot starter validation. All right, don't forget to do that. So as you can see, now we have abstracted away the need to do validation from a controller to some external system or to some external class or framework or whatever you want to call it. So now let's run the same application. This time around, I'm going to call this endpoint put. The attributes are still the same, except that here I have added some, I have added some constraint. All right, so I'm gonna say put, and let's see what full name. Okay, minimum 2, maximum 20. All right, so it should still give us some exception. All right, so as you can see, we have the exceptions here. Size must be between 2 and 20, and we also have age. Here we didn't specify age, so if I was to to specify age here, and age I say 30, that age should disappear. As you can see, age has now disappeared. We see that the controller is not doing any validation, but the validations are being implemented for us using this annotation. So a controller should not do any logic. The responsibility of a controller is to get a request, pass it to where it needs to go, then take back the response and take the response back to the caller. That is the only job the controller has to do. No logic you have to specify in a controller. All right, then let's go to mistake number 4, error handling. So we do not have to handle errors in our controllers. So if you look at this controller here, so what are we doing here? We are throwing this exception and we are handling it here. We are throwing this exception and we are handling it here, as you can see. Invalid exception, and this is the same exception, and then we return the error message. All right, so what I want us to do is we are going to call this mistake number 4 this time around, so we can see what we have. I believe it's post. Okay, all right, it's post. So let's run this code and see what we get. So we see now we have name invalid. And how did we end up getting this name invalid like that? And we have status 400, which is a bad request. The reason we are able to get that is because this exception that we are throwing here was handled here by this code here. This is it being handled, and we get the error from that exception, the message. Then we return back that to the caller, and also the response status. We return back bad request, and then we have to annotate our method with exception handler like this. But this is not a good practice, because now our controller is doing a lot. There's still no separation of concern. Our controller is now handling exceptions, which is not what it's supposed to be. So what we rather do is, let's take out this exception handling code from here, and let's put it in some exception handling code. We are removing it from our controller, putting it where it belongs. So in here, I have this method that I've put here. So now this method will act as a one to handle our exception. So I'm just gonna run this code again. Observe that I didn't remove this not found 404. All right. So let's run this code again. Look at that. Now we get 404 not found, and we also get this message. But input validation is not a 404, so we have to say bad request. All right. So okay, so let me run this code again. I run this code, I get bad request now. So I want you to observe what happens. Let's remove this at response body and run this code. Wonder, see what we get. So the at response body is doing something for us. It's telling the Spring runtime to put the result of this in the body of the response. That's why if now we leave it, we bring it back, it's telling the Spring runtime to put this error message in the body of the response. Now when we run, we have the body of the response. But if we do not do that, if we do not have this, Spring will not know what to do when it when the exception is thrown. Spring will not be able to do the proper processing, and this has to do with message converters. If you know what a message converter is, content negotiation. So when you do this, you are telling Spring to put whatever body of the whatever this message into the body of the response. Then Spring will be able now to give you this message as we have like this here. All right. So what we have just done here is we have taken out exception handling code from a controller into an exception handler. And another thing that I forgot to mention is that we must annotate our exception handler with a controller advice. All right. I'm just going to control click on it and download the source. So this will act like an intercept. It will be applied to all the controllers. So we saw that in the previous case, we had that exception handling code in a controller. But now, when we put it specific in a controller, other controllers will not be able to handle that exception. So what we rather do is we find a way to advise all controllers with that exception handling code, which is what this is basically doing. So that means now this exception handling code would be available to all our controllers, as opposed to the previous one, which was just specific to a controller. So now, if you read the documentation here, it says specialization of a component for classes that declare exception handler at ignore binder or at model attribute methods to be shared across multiple at controller classes. So it's shared by all the controllers, as I have mentioned. Okay, I think that's all with regard to controller methods. All right. Global scope, thread safety. So there are situations or use cases in your application where you will want to share scope or state throughout the entire application. When you are using application scope pins, I'm just going to show you that quickly. So if you look at this code here, let's go to the configurations. I have this configuration and I have this app session, which is application scope, which means we have one throughout the entire application. And then let's see what is inside app session. We have a counter. And what we want to do, we want to increment this counter. Let's say it's a business case. Every time a user performs a certain thing, we want to increment this counter. So that means this state will be available and accessible to any user of our application. All right. But the problem is, as a developer, you might just declare it like this, and obviously here you want to do counter plus plus, and then leave it like this, and then you'll be celebrating, wow, I have the app is complete. Let me tell you that what you have done here is not thread safe. Assume a situation where your application is being is accessed by many threads, like this bin is accessed by many threads in your application, and they are both executing this method at the same time. You are going to have inconsistency. So this bin is accessible globally. That's why in the slide I say a global scoped bin, and it's not thread safe. So what we need to do now is to introduce thread safety here, so that when threads wants to execute this method simultaneously, they won't be able to do that. And we know that there is a problem with this kind of coding. You have race conditions. You have there are a lot of problems with threads that you can talk about. I forgot the other points with threads, but I have also explained that in my video. But you will end up having inconsistency if many threads they are trying to access this at the same time. You will not have the true value of the counter. So the first thing that you want to do is you want to serialize this method. So in Java, serialization can be accomplished by just adding synchronized keyword on the method. So if we have added this synchronized keyword here, it means we have done serialization. When threads want to access this, only one thread can enter this code block, at a time. If the one that entered, the other one will be blocked. The only problem with when you have it like this is that you are synchronizing the entire method. But there are situations whereby your method has multiple, like it has many lines of code in it. Okay, let's say something like this. And the only part of code you only want to synchronize is this part. So this might not be an ideal solution when you just want to synchronize this part. All right. So what we want to do is we want to remove synchronize here. Then we can introduce some locking mechanism with Java. So there is a class called the readWriteLock and equals to new. Okay. All right. So we can do something like this. Then what we want to do here, we can say, because we know that if we enter this method, obviously we are going to change this. So we can say .writeLock.lock. All right. Then when we are done, we have to unlock. It's like you enter the room. When you go out, you must unlock. All right. So we must do readWriteLock.unlock this time around. All right. So if we do this, the thread that entered here first and executed this method, the next thread that wants to come into this code block would be locked, will not be able to enter here. So now this is where the thread scheduler comes in. It knows what it will do. This tutorial is not about that. Or if you don't want to use this readWriteLock, you can use readOnly. You can use this one, and this one you just need to remove this method calls. You will still get the same behavior. So you want to maintain the state here so that a thread, when it calls this method, we ensure that another thread is not currently doing that, and we wait for that thread to complete before we actually execute that code. All right. So we must be careful when we use application scoped beans. And we have to manage the state, as you saw me doing that. All right. Then we have cyclic dependency, which is a situation where two beans are depending on one another. And normally what you want to do is you want to defer the initialization of another bean. And how do you do that? You use @lazy. But this is not a good coding practice, or let me not say practice. When you are using this annotation in your application, it is a code smell. It means something is wrong with your design. And what you want to do is you want to revisit your design and implement it correctly to avoid having to use @lazy, to avoid cyclic dependency in your code. Mistake number 7. Component scanning is a wonderful annotation that allows a sprint to discover beans that are annotated with a stereotyped annotation. But the way you use component scanning can tell whether you really understand it or you don't really understand it. So look at what I have here. I have a component scan org, then I have com. So what I'm trying to do here, I'm instructing Spring to scan this package and also this package and create those beans for me. And this is bad. I'm going to explain quickly why it's bad. And look at this one. I have com, which is the base package I want to scan. So I will scan this and all sub packages that comes in it. So in this one will make sense in this application that I'm using for this presentation. Why will it make sense? Because com is the base package. So you could say in your application, add component scan, then I say com. So this is bad, very bad, guys, and please don't do that. Let's explain why this is bad. This is not only going to look at the com that is specific to your project. It will also look at the com that is in the class path. And I believe we have quite a number of them. As you can see, you have this one here. It's a com also. The base package is com. All right, this one also. Look at how many they are. Look at how many they are. They are a lot. And let's go back to the, then we have awk, which means now that you are going to scan even the, okay, if I was to put this one also, it would mean that I'm also going to scan all of these packages. Look at how bad that is, even for performance. It means I'm going to scan all of this that has the base package as awk. So this is very bad. So if we wanted to scan, let's say we wanted to scan everything that is in our project here, we would rather say awk.example.spring boot. We'll rather do this. So we have been specific. This will only come to our own project. If we have other mistake number 8. So today the use of an auto-wired keyword is almost not required anymore. So you can basically be able to wire your dependencies or inject your dependencies in the bins without the use of this auto annotation, at least with the latest versions of Spring. Before, it used to be a requirement for you to use an auto-wired annotation, either on the field, on the constructor, or on a set. So now, what Spring is, or what we are trying to achieve is, our code does not need to be framework specific. Even things that should be possible with Java without involving Spring. That should obviously be done, if you get what I'm saying. So we want to try and be agnostic in our code as possible. We don't want our code to be too Spring specific. All right. So I'm going to show you something here. As you can see, let me go back. So we have constructor injection like this. So in the older versions of Spring, you were required to specify an auto-wired annotation on top of this controller for the Spring container to be able to inject this for you. But today, this is no longer a requirement, and you don't have to do it. And as you have noticed, we can have a constructor using a Lombok. Then we have that construct, and Spring will be able to inject this dependency for us. The only time when we are required to use an auto-wired annotation is when we are using setter injection. So I'm just gonna create a setter. So as we have a setter here, then in this case we have to use this annotation on top of a setter method. So but we know that Spring recommends us to use a constructor injection rather than setter injection, because setter injection creates an unreliable bin, because you can be able to create your bean with some dependencies missing, and we don't want that. What we want is when a bean gets created, all the dependencies for that particular beans are created at that moment. We don't want a class that can be created possibly without the dependencies being put in place. So at creation, it's like we are enforcing dependence. We are saying this class must be created with this dependency, and that is a good coding practice. All right, then mistake number 9. So there are situations where in our application you would have an abstract repository. All right, let me show you. If I come here, we have an abstract repository. So this abstract repository here would normally be a base repository for all your repository methods. And in here, you will define all methods that are common to all your repositories so that you don't have to duplicate those methods. Then all other repositories will extend your abstract repository and will inherit from it. But with this kind of setup here, the fact that your repository extends JPA repository means that your abstract repository, the Spring container, will create a bin for it also, because it implicitly extends from repository. So this will become a bin. So, and if it is a bin, this is clearly not an intention. You are not intending to have this as a bin. You just want it to act like an abstract class. So that's why I have to annotate it with at no repository bin, which means now I'm telling the Spring container that when it scans for stereotype, for repositories, it must not create a repository for this. It must not create a proxy, or it must not make this a bin. It must not create a proxy for it. And if you look at all the Spring repositories that inherit or that comes below the repository interface, like if we look at JPA repository, you notice that it is also annotated with this. If you look at this list, it's the same. CRUD, it's the same, which means they will not, Spring container will not create proxy for this, for this repository, because you are telling the Spring, okay, let's just read what the documentation says. All right, so it says an annotation to exclude the repository interface from being picked up, and thus in consequence getting an instance being created for it. All right, so you are preventing Spring from creating an instant repository for that your abstract repository. Mistake number 10. And I must confess that this one I'm also guilty as charged. So, but recently I have started doing it. Writing test for our application. Very important. Writing test. Let's write test, guys. Because when you have test for your application, you have a lot of benefits. Number 1, reduce cost. How do you reduce cost? The cost of an application not working in production is higher than the cost that you will have incurred writing tests in advance. Also remember that tests do not really mean complete removal of problems. It just ensures that your application, we minimize errors as much as we can. And so tests are very important. Unit tests, integration tests, let's write tests. And if you look at Spring Framework, they have wonderfully given us so many classes. They have made it very easy to test Spring application, and there's no reason we should not be testing our Spring application. End of the slide. Thank you guys for taking your time to watch this video.